Greeting viewers, in this video we will be designing pulleys. So before we go into the actual design process, let's see some design aspects of this and how does it work. So what are the pulleys at first? Pulleys are the power transmitting devices which transmit the power from one place to another place. Suppose if there is some kind of distance between two places where you want power to be supplied, then you can use the pulley and the belt system. You can also use the chain system and a gear system, and they have another advantage, and these pulley and belt system have different advantages. So for this video we are gonna design only the pulley. So here you can see that this transmits power, and how do they transmit the power? By applying a belt, and they can vary the speed and torque. Suppose that this is the crankshaft pulley here and this is the alternator pulley here. So you can see there is different in diameter. This has got shorter diameter, this has got larger. These all things depend if you want to vary the torque and the speed. If you want to increase the speed, you can use the smaller diameter pulley. If you want more torque, then you can use the bigger diameter pulley. So here you can see this system may be a water pump, or it may be for the AC compressor, it may be for the power steering fluid compressor or the pump, whatever is required, you can use it here. And another thing is that the types of pulley, it may be the flat pulley or it may be the grouped pulley. If this is the flat pulley, then we will need the crown. Crown means these outer surfaces or the outer sections which has got more height. So what is actually the function of this crown is it that it prevents the belt from moving sideways, or to move it from, or to slip it from the pulley. So these are different type of crowns here. So now before going into the actual design process, let me show you a clip. This is how the actual pulley looks like. Let me show you all the sections of it, the front, the center and the inside one, where the parts are assembled, whatever goes inside. So at first let me focus it over the V section. It is the most important part because it helps to grip the belt properly and provides the wedging action during the power transmission phase. You can see the grooves goes all the way, and now these are 3 holes for the 3 screws to put on. And next let me show you the inside section. Here you will see a triangular section which is kind of important. We will discuss it during the designing form. And here one more important thing for the V section is the crown parts. First is here, second is this side. So the function of this thing is to hold and do not let the belt slip away from here. Now let's focus on the water pump. This is the triangular section which will connected with the same side, and this side it is impeller. Both of these are connected via a shaft here. Now you can see the holes here and the holes over here, 3 holes here for the screws. Let me show you how it is assembled. So we put it over here, tight it a bit with hand, and then we screw these, rotate them and then torque them properly as per the specifications of the manufacturer. Now let's see this triangular section here. This is the impression and has got a bit of height. This will sit here. I have separated this triangular section from another water pump. Let me show you how does it look like. And here it goes. We will put it here. Okay, this center section will go inside of the water pump, actually in this way. Okay, so this is how it makes the power transmission possible. Okay, now let's go to the designing process. Go to start, mechanical design, part design. I'm okay with part 1 name. Okay, in this part workbench, let's select a plane at first, and now let's start by sketching some of the reference line we will be using. Let me constrain their dimension. I want it to be 80. want a center line here. Now it depends how many groups we have to make for this design. In this video I will be designing 5 groups. You can make more or you can more less, that depends upon belt and many other specifications. I want this distance to be 10, and now I want more lines, so I will no I cannot use it now. So for the 5 groups, the groups will come here, one here, another one here, so I need to make 6 lines. This distance again 10. Okay, now I can use the mirror image. Let me first click the elements which I want to make mirror, and click on mirror and then click on reference line. So now total 1 2 3 4, one more line. Click here, mirror image it, and click here. Okay, this is all. Now let's start by making the first group. Here, after zooming it, I want it to be started from here, and I will need one more line, one more reference line I mean, and it will go here. Okay, the distance I want here is 20 mm. Okay, looks good. Now let's start drawing the group section. These are V groups, so will simply look like this. Let me make it symmetric. Symmetric means I will have the same distance from both of the 10 mm line. So 5 mm looks good. Now I can smooth out this sharpy pointy thing which are actually required to remove the stress concentration. This radii I want only 1 mm, so it looks good now. Here you can see it has smoothened out. Now what I can do is that I can click on it, take the mirror image with respect to this line. So here I got the another group. Again smooth the sharp edges because it may cut the belts of course, so we do not want it. Now again we will take mirror image, hold control and click all the lines, click on mirror, click here. These are the specifications which we are taking here. These are really important, that depend upon the size of belt, the amount of power you want to transmit, because what it does that it holds the belt here. Suppose here is a belt, so what this V section is doing is that it is providing a contact from 3 sides, one here, maybe one from here, and depends upon belt. So it is providing a wedging action. Let me remove this belt, it is really not desirable. Okay, now again smoothen out these all things. So what I was saying is that these all dimensions are important. Right now I am not paying too much attention toward these all dimensions, but these are important. 1 2 3 4 and one more. Now let's again take the mirror image, click here, here it goes. Now smoothen out this one with the same dimension of 1 mm radii. Okay, here it goes. Now let's connect it here. So now till now we have completed the group sections. Let me show you it in the clip. These sections we have completed. Now time to create this crown section. So how we will design it? Go back to CATIA. Okay, let me make a line here, and I want this this section to be only for 2 mm. Now you know that belt will be sitting here, and there are areas of high altitude here, and this will not allow to slip the belt. Now I will need one more line here. Okay, and I want it to be a distance of 30 from the upper line. Okay, everything looks green here, that means everything is fully constant here, not over, not under, perfectly constant. I want it to be 90, then okay, here. Now we will need to stop here, and now let's design the another crown section which will come this side. This was the rear side and this is the front side. Okay, whatever the distance, just leave it there, and then we will fix the distance of it. And I want this side crown distance to be the same as the rear side, 2 mm. Now let's draw a line from here to here. I want this angle to be 60 degree, so this one is also constant. Now I want one more line or one more reference line. It's better if we constrain these all lines from the XY axis. This will be the perfect thing, but for the sake of simplicity I am drawing it from any constant line. It is also okay, nothing wrong about it, but if sometime we have to delete the center line or we have to modify it, then it may create problems for the other lines. That's why we should always design it from the axes. So now this line, it should be from here, and I want it to be 50. Let me zoom it a bit, pan it. Okay, so the 50 is here and my line is here. Now actually I want this 50 from top side, that means here. centimeter. I'm actually forgetting what was the dimension of it. Just give me 1 second so that I can measure it. No, I was correct earlier time. I don't need it from there. Jet. Okay, this one is okay. This line should be around 50 mm from here, that means 70 from there. It's okay. Now now this line and the other line which I will be drawing in this section are the front side. What does it means that this is this section we have designed till the crown section, and now I will design this front side. Okay, go to CATIA. From here I will draw a straight line to here, then I will mix this line. Now the only thing remaining in this 2D is to smooth out all the sharp edges like this. I want it to be 30, not 35. It's okay. Let me zoom it a bit. On this side I want radii of 1, or I can reduce it from 1 to 0.5, that will be better. Here let's put it 0.5, not 1.5, 0.5. Okay, this looks better. And now 2 more edges are remaining. here. Let's make it 3. Okay with that. Again this side, let's make it 1.5. Okay, so this is the whole 2D profile. Now the only thing is remaining for us in this 2D profile is to check if this is completely closed or not, otherwise it will create problem. And congratulations, it is closed. So now for this video I think it is enough. In the next video we will revolve it or rotate it and then create the 3D images. So keep watching and wait for the next video. Thank you.